Hello, my name is Omar Elshemy, and today I'll be explaining question 2 in this exam's question code. I'll be walking through it step by step, so if you'd like to follow me, feel free to do so. Alright, so for the first part of the question, it asks us to fill out this table right here. So we can begin by starting out with the first column. It says here, cobalt with an atomic mass of 59 is a cation with a positive 3 charge. As we know from this periodic table up here, cobalt has an atomic number of 27, which is why the number of protons is 27. Now to find the number of neutrons, all we have to do is subtract the atomic mass, which is right here, the 59 minus the number of protons, which is 27. So 59 minus 27 would be equal to 32. So that would be the first box right here. Next up, it asks us for the number of electrons. And since this is a positive 3 charge, we know that the number of protons is 27. So all we have to do is subtract the number of electrons here from the protons, because we cannot change the number of protons, because doing that would change the actual element itself. So all we do is 27 minus 3, which would equal 24 electrons. Now for the next one, it asks us here for the number of protons. Now since this is still cobalt, as previously mentioned, the number of protons is the same because it's still the same element, so this would still be 27. Now for this one right here, it asks us for the symbol. The symbol is basically just the symbol of the element and the atomic mass. So first it gives us the number of protons, so we can look here at the periodic table and find out that I, or iodine, is the element with 53 protons. So we'll just put iodine right here, the symbol for iodine. And then all we have to do to find the atomic mass is add the number of neutrons and protons together. So it would be 72 plus 53, which would be equal to 125. So the symbol for iodine would be 125I. For the next part of the question, we are asked to state why cobalt-60 is used in radiotherapy. Now, radiotherapy is the use of radiation to treat cancer, and cobalt-60 is a radioactive isotope. So you could say that cobalt-60 is used in radiotherapy because it is a radioactive element, a radioactive isotope, which means that it helps treat cancer cells. For the final part of the question, we are asked to find the full electron configuration of cobalt-59 with a positive charge of 3. Now, this was the same cation that was in the first part of the question in the table. And from that, we know that the number of electrons in it is 24. And as we see on the side right here, is that these are the different types of sublevels, and each one can carry this many electrons. Now, using this information, this would be the normal electron configuration of cobalt-59. However, this is not the case because this part right here. Now what this does is that since this D is not complete, the atom is unstable because this 4s2 is complete. So what we can do is move these electrons over to here and make the atom more stable, which is what the true electron configuration for cobalt-59 is. And this would be what you would write for your answer if you were asked to state what the full electron configuration of cobalt-59 with a positive charge of 3 is. Alright, so here is the mark scheme for the question. For the first part with the table, we got all of it correct, so we were awarded both points. For the second part, we mentioned how cobalt-60 emits radiation which kills cancer cells, so we get the point for this one. And again, as mentioned, the 4s wouldn't apply here because it would make the atom unstable, the atom unstable, so this is why this is the accepted answer. And the abbreviated form would not work because the question specifically asked for the full electron configuration, not only half or abbreviated. So yeah, if you followed along and you got it right, then great job. And yeah, thank you for watching.